So far in our examples, we've been working through ordering chains where every single variable is on a single ordering chain. But sometimes you're going to have variables that are not part of an ordering chain, or you're going to have rules that are separated and can't be incorporated into a single ordering chain. And I want to talk about the impact of those issues, what I think of as free agents, meaning letters that don't have any rules about them, and unconnected rules, rules that you can't quite put together into a single ordering chain. So go ahead and start by trying to combine the first three rules here, 1, 2, and 3. That should end up looking something like this, where G is before A and Q, J is before A, and L is before I is before Q. I've checked off these rules because I've already combined them together and I don't need to worry about rules 1, 2, and 3. How do we handle this I not in 6? Well, I'm going to start by drawing a restriction underneath the 6th spot. I can't go in 6. But I also want to add this restriction directly to my I in my diagram. It just makes it a little bit easier to remember that I never goes in 6. Now, as I was initially diagramming the rules, I would have put a tick mark above all the letters that are mentioned, and then if you do that and circle whatever remains, you're going to be left with an M that is a free agent. It has no rules about it. Although everything else is mentioned, M is not mentioned. So I'll handle this by just drawing the M, basically recopying the M closer to my diagram. It's already pretty close enough, but the closer the better. So now let's talk about how the existence of a free agent and how an I not going in 6 slightly changes how we're going to read our diagram. First of all, who could go last? Now, ordinarily, you might think it would be A and Q as the only letters that could go last, but don't forget about the M, because the M has no rules about it. The M could also fit at the end. So that's how free agents can affect things. When you're thinking about who could go first or last or in any other spot, you have to remember the free agent. Now, what about this question? What is the latest that L could go? The latest that L could go. Now, ordinarily, you might think it would be the 5th spot because the L only has I and Q that have to come after it, but the issue is the I can't go in 6. So if you tried to put the L in 5, that would force the I in 6 and the Q in 7, and now we end up with a contradiction. So the earliest spot that the L could go is actually 4, not 5. We have to be careful about those rules that present us with restrictions about where letters could go, because they will slightly change the way that we're going to read this diagram. Here's another challenge for you. Go ahead and pause the video, try this question, and we'll discuss it when you're done. So the first thing I'll do after having diagrammed these rules is try to connect any rules that I can connect. I can see the J is before P and S, and that means the J is going to be before P and Z. I can see that the P before Z could be attached over here, but the M-O-Y is not going to be attached to rules 2 or 3. In addition, O can't go in 2, and that's something I'd also want to write directly onto the O in my diagram like this. So hopefully you came up with something similar to this. Now, before we go to the questions, I do like to think about who could go first and who could go last. And it looks like the M and the J are the only letters out of these 7 letters that don't have anything before them. So that's why it looks like J or M could go first. And the Y, Z, or S, these are the letters that could go last. So let's take a look at number 1. List all of the slots in which J could appear. J has to have P, Z, and S after it, so I know J can't go in 7, 6, or 5. And so is the answer 1, 2, 3, and 4? Could J go in all 4 of these spots? Actually, no, and this is the point of this lesson. We have to be a little bit more careful when you have unconnected rules, especially when you have these restrictive type of rules, rules that tell you certain letters can't go in certain spots. If you try to put the J in 4, then you know that the P before Z as well as the S are all going to occupy these last 3 spots. But what does that mean about the remaining letters, the M, O, and Y? Well, that means that they are going to be forced into 1, 2, and 3, and there we have our contradiction. O can't go in the second spot. If you try to put J fourth, then O is going to be second, and that's not allowed. So actually J cannot go fourth. But what about third? Could J go third? If you try to put J over here, I know that the P and the Z are going to come somewhere in the last 4 spots. I also know the S is also going to come in the last 4 spots. But there's one more letter that's going to have to go somewhere in 4 through 7. And that's going to be our Y here. That's because M has to come before O and Y. And do you see that if you try to put M on the right side of J, you're just not going to have enough space to put M, O, and Y, and S, P, and Z. And in addition, if you try to put the O to the right of the J here, somewhere over here, well, you're not going to have enough room for the O and Y, as well as the P, S, Z. That's 5 different letters. So in order to fit the M, O, Y relationship, these 2 letters are going to have to go down to 1 and 2, but do you notice we run into that same contradiction? Putting J in 3 ultimately forces the O to go in 2, which is not allowed. So J cannot go in 3. It turns out the only places that you could put J are 1 and 2. If you put the J in 2, then you're going to have enough room for P and Z somewhere after, as well as the S. The M is going to be forced into 1, and then you know that the O and the Y are also going to be coming somewhere in 3 through 7. And you could also put the J in 1, in which case there's a lot more variability as far as 2 through 7 go. You could put the M in 2, you could put the P in 2, you could put the S in 2, but no matter what, there is going to be a combination that works with J in 1.